Let's continue our math adventure. Today, we are entering the world of banking. And we know that we can deposit our money into banks or into investments, and we can earn money on that. And the amount that we earn is based off of percentages that we get paid. Now, there's two types of accounts that we could deposit into. We could deposit into an account that gives you simple interest, or we can deposit into an account that has compound interest. You need to understand the difference between the two of them. So a simple interest account means that you're going to take some money and you're going to deposit it into a bank, and that bank has agreed to pay you a percentage on that money. The reason why they do this is they don't hold that money in the bank. They actually loan that money out to other people, so they're using your cash. They don't have a box that has your name on it with that amount of cash in there. So they're paying you for that service of them being able to use your money. Now, the percentages that they pay you are set from outside sources for that. So they don't just get to decide that percentage, they're kind of told what that percentage should be. So if we had an account that had simple interest, what we want to see is what our account balance is at the end. It's made up of something called principal, and principal is the amount that we put into the bank. Then we have an interest rate that's paid to us, that's in a percentage rate, and there's an amount of time that we leave it in the bank, and so that's what our T is. So there's a simple equation that banks use in order to calculate how much they're going to pay you and what your final balance is going to be. So say I went to the bank and I decided I had $500 that I want to put into a savings account that pays simple interest. Well, that $500 represents that principal that I put in. Now, to calculate the interest amount or dollar amount that I'm going to get paid by the bank, because really what the bank is doing is they're paying me to use my money. Well, the way we calculate that is we take the principal, we multiply it by the percentage rate that they're paying and the time. So say they're going to pay us 7%. And we're going to leave it in for 4 years. So I take my $500, I put it in 4 years, I don't touch it. At the end of 4 years, how much money would I have? Well, in order to calculate how much they're going to pay us, we take our 500, we multiply it by that 7%, but we change that to a decimal of 0.07, and we multiply it by 4. That amount is $140. That means the bank is going to pay me $140 in order to use my money. Now, my money didn't disappear. That $500 that I started with is still there. And so when we take our $500 and we add our $140 in interest, that means my bank account 4 years from now would have $640, and that is a really good interest rate. So by using this one formula, not only can we calculate the amount of interest we would earn, but we also can then see what our final balance would be in the account for that. Now, if we're thinking about simple interest, all we're getting paid on is that initial amount that goes in. So the way that it works, if I put $100 into the bank, and after the first year I made $10 of interest, which would be fabulous if we could do that, that means I'd have $110 in my account at the end of year 1. When they go to calculate interest in this second year, they start back at that original $100. I'm not getting paid on that extra $10 that I earned. I'm only getting paid on what I put into the bank originally. So say in year 2, I got a little bit better interest. I got $12 on that. Well, really, my original amount that I put in was the $100. I got $10 the first year. I got $12 the second year. So now I'd have $122 in that account. So that's how simple interest works. We're only getting paid interest on the original amount that we put in. Compound interest, however, is really what you want to go for. A lot of investments that we do, it's compound interest, because in compound interest, we get paid interest on our interest. So let's see how this one works. Now, the formula looks daunting, but don't worry, it's not that difficult. B kind of represents what that A represented. It's just what my account balance at the end is going to be. So even though they use different letters, I think they do that just so that you know they're different calculations or formulas in order to solve them. So B equals P. P still stands for our principal. That's a 1. R still stands for my percentage rate. T still stands for time. But this gets interesting because we know when we have an exponent, it makes things grow faster. If we're thinking about compound interest, we're really thinking about we put in an amount and then it starts to increase in value very quickly. That's the beauty of compound. We make more money. So when we go to do this one, say I had $800 that I put into an account and I'm going to get 5% interest and I'm going to keep it in for 3 years. Well, I just plug it into the formula. So P is my 800, 1 stays 1. That kind of represents that whole, I'm starting at $800. So that's like 100% of 800. My R, my 5%, I changed to a decimal. And that exponent of 3 for my time, I just place it for the T. Now, when I add those percentages together, I get 1 and 500ths. Notice it's already in a decimal. I don't have to change it from a percent. Now, we have order of operations, and we know we have to do exponents before we can do multiplication. So first I have to take 1 and 500ths times 1 and 500ths times 1 and 500ths. That's what that 3 represents. I have to do it 3 times. When I actually calculate that, I get a long decimal. Don't round it. You have to use all the decimal places. Never round until your final answer. So when I multiply it times itself 3 times, I get 1.1576. Well, that $800 that I put in still remains there. So now I'm going to multiply $800 times that decimal and I get $926.10. So that means in 3 years time I went from $800 to $926. I gained an extra $126. So what's the difference? Well, in compound interest, if I put in $100 and I gained $10 that year, I'd have $110 at the end of year 1. But here's the beauty. That $110 is where I start in year 2. And in year 2, then I have my $110 and I add another $15. So I just made interest on my interest and I'd end up at $125. So notice in compound interest, you gain interest faster than in simple interest. So if you can get your money in a compound interest account, that's what you're going to want to do. The job is up to you. It's time to calculate our interest. Good luck.